Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Helmi Wira Haikal. I'm with Ikhsan Assidiqie and Zharfan Dawud Harwiraputera. This is an a solo presentation because the first half of our video is corrupted, so I will be doing this solo for the time being. Okay, this is uh, our duties. I will be the moderator and background introduction. Ikhsan will be demonstrating the knife base and presenting that also. And Zharfan will be presenting the key and demo. So our project is to see the accuracy of the algorithm, to know the percentage of the people afflicted with arrhythmia. We will use knife base and KN algorithm. Before we do the algorithm, of course, we set up the hyperparameters. Hyperparameters are the parameters whose value controls the learning process and determine the value of model parameters, ultimately taking shape of our algorithm. Now, what are the hyperparameters that we use? The parameters that we use are only feature selection, sadly. Feature selection is picking specific features or attributes to be used when searching the accuracy. In this case, we will using 5 of them, which is heart rate, TRS duration, age, weight, and gender. All of these have correlation to the heart of the patients. Heart rate, of course, is self-explanatory. TRS duration is the consistency of the heart rate or the heartbeat. The age could mean the older the person could lead to higher risks of diseases. The same with weight. Obesity, people with obesity have higher risks to get a disease. And gender, of course, because men and women have different heart rate, heartbeat per minute. First of all is naive Bayes. Following Bayes' theorem, his algorithm assumes that the data is independent from each other, which means that they are not um, dependent on each other, but still relevant, but doesn't have any correlation that could affect their value. This is the Bayes theorem. This is not important to our algorithm. This is the flowchart that we use. It will start by reading the data arrhythmia patients here. Then it will be pre-process the data. The process, like I said before, is by using a feature selection that we only use heart rate, QRS, age, etc. After that, we split the main data into training and validation. With focusing on the training data, we split the truth value of it and then calculate the mean, and standard deviation of attributes or features of each class. After that, we predict the diagnosis based on the features that we have chosen, again, or the 5 of that we pick, and see the accuracy of it, ending the algorithm. After that is the k nearest neighbor, or KNN for short. Is a method that classifies or predicts the label of a new instance by their neighbors. The neighbors here is chosen by us. The k value is chosen by us, whether it is 1, 2, 3, or 6. This is the flowchart of it, how it works on our algorithm. First is, of course, the same as knife Bayes, reading the data from arrhythmia patients, shuffle the data, then split the data into 3 pieces. After that, we process the data. A little bit different than naive Bayes is that despite we choosing the 5 features, like the feature selection, it actually still use the other attributes of features that exist in the data, but only ignoring the data that is this have discrepancies, such as the value is 0, the value is question mark, and so on. After that, we insert the value of k, like I said before, 1, 2, 6, whatever that you want. After that, we calculate the mean of accuracy. Okay, this is demo session. Then I will cut this into the to the original video. Naive Bayes will be explained by Ikhsan Assidiqie, and K nearest neighbor will be explained by Zharfan Dawud Harwiraputera.
Screen my screen. I'll take over from here. Okay, I will try to start by importing the relevant libraries such as pandas and math or such on, and then I want to create a read CSV to read a relatable file, and then I create the columns to ignore for the first time, and then I try to gather info from the describe and the shape method. After that, I want to find the missing data with missing data variable with pd.data frame. Uh, Program, and then I want to visualize just for insight for my research only. And after that, I implement some box plot and scatter plot just to see the outliers, just to subtle outliers just like this. Then I try to removing the outliers using IQR methods. And after the method is done, I try to I try to run the selected features, which is the indices. Then after that, I try to run again just to for inside the data visualize, and then yeah, the removing outliers is success. And as you can see, the data is more clean right now. Then after that, I want to normalize. I want to normalize the data using normalization function. And after that, I create a variable called norm train, which is the normalization that passing the selected features as the parameters. And after that, I create a naive bias classifier with calculation probability with three parameters, mean, standard deviation, and x. And then after that, I try to split through the column. And after that, I try to print several data just for insight, and then create a find mean function, and after that create a find standard deviation. And for the line 33, I create a do predictions class with such as parameters for parameters class means that passing standard deviation, the target, and the truth column, and then validating the model as the stage 5 for the last stage also, with a three location difference, left, right, and middle, with each location has equal with almost 33.3%. And after that, I try to create a variable called train data and validation data with folding as the df clean or selected features as the parameter with training percentage around 80 to 85 with the location of left and the shuffle is true. And after that, I create a result as the variable for do prediction that passing the train means and the train standard deviation and also the train data from the above, and passing the diagnosis column name and printing the result, and create the confusion matrix for calculating the probability like true positive, true negative, false positive, and false negative. And then I call the confusion matrix with passing of result and 16 classes with the result of accuracy 96% with the precision of the data is 69.3% and the recall is 73.6%. Okay, that is for me for knife bias. I will try to pass for Zharfan. Zharfan, please take your time.
Okay, thank you, Iksan. So, as opposed to the knife-based classifier, I will be presenting about the KNN classifier, which is far more easy to implement and to understand. So, what the first part is pretty much the same as how we implement for the a knife-based classifier, where we use the read CSV function here that we made from scratch, where it basically use the delimiter of a semicolon from the CSV file, right? And then we want to put the columns to ignore, where we want to ignore the columns, where these are all are basically the columns that contains all instances where its value is zero, and features that contains a missing value. So we just basically drop them all instead of doing an imputation or any other method to resolve it. So the next part, we do the data exploration, where we just basically see how the data train or data frame that we get from reading the CSV file results in, right? We want to see how it looks like in general. We want to see the description of each instances, right? So on. We see that like this, and then we just try to see the first 11 instances, so on. And then the next part is the data processing. Although keeping, you may notice that we basically already done a small data preprocessing here by dropping some of the attributes, as I mentioned before. But this is where it basically the main part of the preprocessing, where we do the data scaling, the folding, and so on. So at first we shuffle the data by using this simple syntax from the library, and then we assign it to the data, the df, or stands for the data frame variable. And then we do the folding, where we basically splits the data into 3 parts here and assign each of them into fold 1, 2, and 3, and so on. And then we do the data scaling, where we chose to use the normalization data scaling. Then, so notice that when we want to scale the data, we don't want to scale the actual data target, because it represents as is, right? If for example, if it's a Boolean target value like 0 and 1 only, we don't want to normalize them or scale them, right? Because it's already what we try to predict. We don't want them to be an of fuzzy number. So that's why we drop the diagnosis and put the rest of the instances, and I mean the features inside X, and we put the diagnosis part only to the lowercase y, and then we normalize the actual data that we want to normalize, and resulting in for the following data. And then to the main part here, the KNN classifier, it's pretty much we pretty much implements the already pre-existing formula for to do the KNN classifier, right? We do keep in mind to calculate the distance between two coordinates in KNN, because we do need to calculate two different coordinates, right? And we try to check how well does it do, like so on, and then the KNN program itself, the main part of this whole program. It is basically an implementation of how the can and formula should work by, and we just implement it and as follow. Then we also want to check the accuracy and evaluate the actual model, how it do, right? So, and then we finally appeared into the main part here, where we want to put the K and we want to see how well the model do. So if I just do the run all button here, you notice that it takes quite some times actually, because we don't really keep in mind the data pre-processing in the KNN classifier as opposed to the knife base, because we want to see how well does it do differently by using a different approach of features. You can see that it while we're using a k of 6, a neighbor, the closest neighbor of 6, it takes quite some times to calculate for each folds, right? We calculate it from the folds, the data that we will have fold, and we put into the fold 2, 1, 2, and 3, and so on, and we try to test it one by one. And it will be take one time now, and there it is. Notice that it almost take a whole minute, because this is simply because we we done very poorly on the data preprocessing, resulting in the following time result. Because when we have such bad preprocessing part, the model pretty much also will do poorly. So I think that is all for the KNN classifier. I will throw it back to Helmi as our MC. Thank you for your attention.
Okay, thank you, Zharfan. I will share screens again. So the conclusion is that naive Bayes gave us a satisfying result based on the numbers, but this happens due to poorly designed confusion matrix expansion. Uh, we think that there's a potential error in that confusion matrix, so that it the affect our results, and it may be wrong, but we are not sure, so we still take it. For the K and N, we get a very bad result. This is because the bad pre-processing that happened during the pre-processing, of course, because as I said before, the feature section still use all the features but only ignore only the zero and the question marks, and making it very low on the accuracy. And that is all for us. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.